So today I'm going to solve this foursome problem, and this problem is basically the same as the previous problem, like problem 15 threesome. Um, in short, it's just one more layer of for loop than the threesome problem. So let's go through the problem quickly. Um, the problem asks us to find unique combinations of four elements choosing from a given array of integers. And one element should only be used once, and we only include unique combinations in our solution. So basically we want to first simplify this problem into a like two-sum problem. We just find two elements from the array and we add them together, and we want the sum to be a given target. Um, so basically here we are using two pointers, like one pointer from the smallest to the largest, as we said previously in that threesome problem, and one pointer from the largest one down to the smallest. They're moving towards each other, these two pointers, and the core idea here is that if we find, like, for instance, the sum of uh, two elements, for instance negative 134, for instance, our target is to get a zero to let's say the sum should be zero. And now here we see, like, a negative 100 plus 34 is a negative number, is smaller than 0. And since 34 is the largest one in the set, so which tells us that this negative 5 is absolutely hopeless, since even the largest one cannot make it to be 0. And the same thing applies here. For instance, now we try negative 20 and 34, and note that negative 20 plus 34 is 14, which is larger than 0. And we can now tell that 34 is hopeless in this set, and we do not need to try other combinations including this element 34, since even the smallest one remained in the set, negative 20, cannot make it like negative number or make it equal to 0. So it's always going to be positive if you include 34 in the combination of two numbers. All right, so I won't just include too much detail about this idea, since it's already fully introduced in the previous threesome problem. So here we're directly going to do the coding. So basically the idea here is that we need two for loops, and then two pointer, like while loop for these two pointers in the inner part. So for instance, we get first for loop for I, and I will just go through all the elements, and then j comes after I, just one element after I. And then inside j here we'll get a while loop to do the two pointers. And then I think this can just include all the possible solutions, and we will be in a good shape if we do it correctly. All right, so we will just directly go to the coding part. So here we just first initialize the solution set equals to new array list. And then we will directly go to the first for loop. So for I equals to 0, I smaller than nums dot length minus 3. Note here is minus 3, since we need to leave space for the other 3 elements after it, since now for each combination we need 4 elements. And then so we also need to skip all the repeated elements. And this idea is also included in the previous video, so I won't just say too much about it. So for instance, here we get 2 negative 4. We only need to check, maybe for instance now I is pointing to the first negative 4, and we're done with all the possible combinations starting from this I equals to negative 4. Then we can just simply skip this negative 4, since otherwise if we do it again, we may get duplicated same combinations, and we only need unique solution here. Alright, so we do that. So if I is larger than 0, we need this condition, this first condition, I is larger than 0, to avoid index out of boundary errors. Nums I equals to nums I minus 1. Then we continue. We just simply skip this element. And then we do the second layer of for loop for the second element in this 4 elements combination. So for instance, I and int j equals to I plus 1. And then j is smaller than minus 2, leaving space for the other 2 elements. And here we also need to do the condition to avoid duplication of element j. And note that here we need to write j is larger than I plus 1. So we need to make sure that at least we went through the first element in the list, the first element after I. So for instance, if we look here, we may get like every single element in the given array is the same, like 2, 2, 2, 2, 2. Then firstly, we will get I pointing to this first 2. So let me write it down here to make it more clear. So for instance, yeah, arguably, we get just all 2s. For instance, 5 2s, right? So firstly, maybe our I will pointing to this one. So I pointing to this one. And then our j will start from the one after I. So j will point to this one, right? And oh, note here, the target is 8. So we can definitely find one unique solution, like 4 2s, 2, 2, 2, 2. When we plus them together, it's 8. However, if we directly check if nums j equals to nums j minus 1, we will get a true, and then we will get true every time. Since know that every element is the same, then we will skip that the only possible solution, like 4 2s, right? We will just return an empty list, which is not correct. So we want to make sure that at least we check the case for the first element pointed by j. So here we need to write j is larger than I plus 1. And then it's basically the same thing. So nums j equals to nums j minus 1. And then we do continue. And now here, after doing all these stuffs, we can starting to do our 2 pointers. So our first pointer in k equals to j plus 1, starting from the elements right after j, and our int s, the larger pointer, the pointer starting from the top of the array, of the sorted array, is equal to nums dot length minus 1. And now while s is smaller, when k is smaller than s, we wanna make sure that we can get all the possible combinations of the 2 required numbers. And now we get, note that here we actually need a long. We, instead of an int, since for some cases, for instance, the input may be very large. The input it's still a int, but it can be almost just close to the maximum value of int. If we plus 2 of them together, sometimes we may get overflow, and this may return us a very small negative number in the type of int, and this can make our whole program fucked up. So we need to use a long instead. So long sum equals to, here we need a type, so we need to here to transform int into long. So nums I plus nums j plus nums k plus nums s, right? So here we need to do the comparison. So if sum equals target, so which means that we find a combination of 4 numbers successfully. So we need to record this result into the list. So list.add, and here we need to do this arrays.addList, and here we just put all the 4 elements in it. Right, so yeah, that's it. And then we need to move the 2 pointers, k++ and s minus minus, in order to kind of continue searching in the remaining array to see, since there may not be only one, there may be more than one possible and suitable combinations of 2 elements in the remaining array that can make the sum of the 4 elements to be the target. So we do not want to miss those cases. And here we also need to skip the duplicated elements for both k and s. So while k is smaller than s, in order to avoid possible index out of boundary problem, and here y just k smaller than s, why k smaller than s can avoid possible index out of boundary problem is, I think it's well explained in the previous video, the 3-sum video, so I won't just say much about it here. So k is smaller than s, and nums k is equals to nums k minus 1. Note that k is going upwards, so we need to compare it with its previous one. So the previous one is k minus 1, so we do k plus plus again. However, for s, we need to know that here it should be s plus 1, since s is decreasing, so the previous one is actually larger than the current one. Right, here we do s minus 1 again, and hopefully this will give us the right answer. So we return list, and we run and we submit code to see if there's any problem in it. Seems like we get infinite loop. So let's see what happens. If I is larger than 0, I minus 1 continue. If j is larger than j, continue. J plus plus, it seems okay, at least so far. And then while, oh right, we sorry, my bad, I forget to write other cases. So for instance, sum can be smaller than target, which means, as we said before, sum is smaller than the target, then we need to discard the smallest one. So we need to do k plus plus. Otherwise, we need to discard the largest one. So we do it so, and I think it will be fine now. Wait, so it seems like we have skipped many possible solutions. So let's find out why. Oh, the problem is actually quite silly, since I simply forget to I forgot to sort the array. So yeah, clearly everything won't work well if the array is not sorted. So we first sort the array. So now everything should be fine. The reached end of while parsing. Oh, I accidentally deleted one more. Yeah, so see here, but however our runtime is relatively long. See, we consume 19 milliseconds, and which means our code is not efficient enough. So let's do some optimization on it. So actually the optimization is quite similar to what we did in 3-sum. Sometimes we can know that a case is hopeless before we jump into it. For instance here, like say for this negative 100, so for this one, we can see that so for instance for this negative 100, if we add it with the 3 largest elements in the remaining array, which is 0, 9, and 34, we get some negative number. And for instance, the target is a positive number. Then we'll know that this negative 100 is clearly too small and it's hopeless. So we do not even need to try any cycle on this one. And the same thing applies to, for instance, and the same thing applies in another way. So for instance, for like, let's see, like for this negative 4, if we add it with the 3 smallest elements in the list, so for instance negative 4, and 0 and 9, is gonna be 1, right? However, if this 1 is larger, it's already larger than target. For instance, the target is negative 20, let's see. Then we do not need to try all the rest of the elements, since we are already in a position that any elements chosen, like any 4 elements chosen, is going to be too big. So here we need to write down the logic and know that we need to be very careful about the overflow problem. So let's see, if nums I plus nums I plus 1 plus nums I plus 2 plus nums I plus 3, the smallest one is already, the smallest possible sum is already larger than target, then we need to break. And know that here we need to do a type conversion to prevent overflow. And the same thing here, like nums I plus nums, so nums dot length minus 1, we need to get the 3 largest one in the remaining array. Nums dot length plus 2 and plus nums dot length minus 3, and it's still smaller than the target. Then we need to discard this I, but not all the rest of the array, since later on when the I is incremented, we may get a larger starting elements. The elements pointed by I may be larger and larger, and we still may get hopeful solutions in the remaining elements of the array. So we need to just simply do continue. And the same thing here. So if long nums I plus, no, here we need to work on the cases for j. So nums j and j plus 1 plus nums j plus 2 is already larger than the target. Then we need to break if long nums I plus nums j plus nums dot length minus 1 plus nums dot length plus minus 2, it's smaller than the target. Then we need to continue. Okay, and it looks good. Let's run the code to see the result. Here we can see that we reduce our time. We only now consume 3 milliseconds, which makes this algorithm to be like almost the fastest algorithm for this problem in this world. And so far we have successfully solved the problem. And lastly, let's analyze the time complexity of the code. And it's actually quite similar to the 3-sum one. So here, sorting the array takes n log n. And here the first loop is n it's n, and here the second loop that travels through all the elements is another n, and here it's also an n. So in conclusion, we get n times n, which is equal to n to the third power. And considering the sorting at the beginning of the algorithm, we get n to the third power plus n log n. Since n log n is significantly smaller than n to the third power, so the time complexity is just n to the third power. And talking about the space complexity, here we consume sum, but the sum only, this variable is created only after the previous itself has been destroyed, so this only consumes linear space, so it's O1. And here for those conditional statements, we also consume a linear space, so the space complexity, I think it's gonna be O1 if we write in big O notation here. So like O1. Right, okay. So here's all. Thank you for watching. If you want to see anything, or if you have any problems and questions about this video, please leave it in the comment. And see you next time.